In this video, we're going to talk about definite integrals. First, let's talk about properties of definite integrals. The first property we need to talk about is zero. When you have a definite integral of f of x from a to a where the lower limit and upper limit are the same, then the whole thing becomes zero. Now think about it. If the lower limit and upper limit are the same, that means the width is zero. And zero times any height will give you the area of zero. So if you have, let's say, integral from -2 to -2 of x squared dx, that would equal to 0. Next, we have additivity. If you have an integral of f of x from a to b plus b to c, that would equal to integral of f of x from a to c. So the example will be like integral from, let's say, -2 to 1 of x squared dx plus integral from 1 to 3 of x squared dx. This will be the same thing as integral from -2 to 3 of x squared dx. Next, we have order of integration. If you have an integral of f of x from b to a, and that will equal to the negative of integral of f of x from a to b. If you change the order of the lower and upper limit, then the negative comes out. So for example, integral of, let's say, 2 to 4 of x dx, that will be same as negative of integral from 4 to 2 of x dx. Next, we have a constant multiple. Let's say k is any number, any constant. If you have an integral of k times f of x dx from a to b, that is equal to, you could take the k outside the integral of f of x from a to b. So let's say you have integral of, let's say, -3 to 4 of 7x squared dx. And that 7 is a constant, so that will equal to the integral of 3 to 4 of x squared dx, and that 7 could come out of the integral. And finally, we have sum and difference. Let's say you have an integral of f of x plus or minus g of x dx. These are two different functions from a to b. That will equal to the integral of f of x dx from a to b plus or minus integral of g of x dx from a to b. So if you have, let's say, 0 to 2 x squared plus 2x quantity dx. And you could separate it as 0 to 2 of x squared dx plus integral of 2x from 0 to 2. Let's look at some examples. Suppose that these integrals are given. And it says find each of the following integrals if possible. So first thing that we need to look at is we need to evaluate integral of f of x from 4 to 1. Well, you know that this is the same thing as negative integral of 1 to 4 of f of x dx. And this portion right here is given. That's -2. So this is going to be negative times -2, which is going to be +2. What about integral of f of x from -1 to 4? Well, from what's given, you know that you could break this down as -1 to 1 of f of x dx plus integral of 1 to 4 f of x dx. So you know that negative 1 to 1 f of x dx is 5. And then integral of f of x from 1 to 4 is negative 2. So 5 plus negative 2 will be 3. That's the integral of f of x from negative 1 to 4. Now, how would you evaluate this? First, you could break it down as 2 is a constant, so 2 could come out. 2 from integral of negative 1 to 1, f of x dx, and 3 is a constant, so plus 3 integral of negative 1 to 1 of h of x dx. Now, is this given? Negative 1 to 1 f of x? Well, that's going to be 5, so this is going to be 2 times 5. What about h of x from negative 1 to 1? Well, that's going to be 7. So it's plus 3 times 7. It's going to be 10 plus 21, which is 31. Okay, what about integral of f of x from 0 to 1, which is part D? From given information, this is not possible to evaluate. We need more information to evaluate the integral of f of x from 0 to 1. So for example, if they give us the information about negative 1 to 0 of f of x dx, then we could find out what this is, since information about f of x, integral of f of x from negative 1 to 1 is given. But since we don't have this information, this is missing, therefore we cannot find the integral of f of x from 0 to 1. So it's not possible. What about integral of h of x from negative 2 to 2? This is also not possible to evaluate with given information. Only information we have about h of x is from integral from negative 1 to 1. But this one goes from negative 2 to 2. And we don't know what's happening between negative 2 to 2. So this one is also not possible. What about integral of f of x plus h of x from negative 1 to 4? If you break this down, you're going to get negative 1 to 4 of f of x dx plus integral of h of x from negative 1 to 4. Okay, this is given. We know that that is 7. However, this is not given. So we don't have enough information to evaluate this integral. Therefore, it's not possible. Graphically, this is what's happening. When you have integral of f of x from a to c, what you're doing is you're taking the integral of a to b of f of x plus integral of f of x from b to c. So that's how you kind of visualize graphically when we talk about combining integrals.